Okay, hello guys. So we are doing Strivo DP MCM. Uh, I'm a little sick today, so don't mind that. Given a sequence of matrices, find the most efficient way to multiply these matrices together. Efficient way is the one that involves least number of multiplication dimensions of the matrix are given. Then n is equals to number of matrices plus 1. Okay, so there are n minus 1 matrices. I where ith matrix is a of dimension array 5. Okay, cool. So in this array there is the three matrices. One is of size 2 into 1, 1 into 3, and 3 into 4. Cool. There are two ways to multiply m1, m2, m3. Okay, yes. My god. I've never done these problems. I don't know anything about these. Let's just read selection sort once. You find the lowest number and then you put it at the front. I think that is selection sort. Exactly. So you find the min element and then you swap. Find the min element and you swap. Find the min element and you swap. Bubble sort, you swap when you find a discrepancy. You do this n times. Insertion sort. Huh, I forgot. Yeah, you insert the element into its correct place. Reach to 5. You start swapping, and at the end, I'm a little scared from MCM. Merge sort, I know. You basically merge, like divide the array into two, and then you sort, uh, ba- and then you keep on dividing. Then when you get the result, you just merge them. Recursive bubble saw, recursive, like merge sort but partition. Quick select also. Why I am so scared of MCM? I'm just scared. Uh, uh, I'm very scared from MCM. Who asks such question? Obviously, it's 8 points. 1, 2, 3, 4. So it will take n minus 2 passes. I can find write a recursive solution in an interview situation, but I don't find it to be very good. Mm. Mm. I'll be back.
Home, baby, home.
Okay, so how can we do this? Basically, when I am at a point, I can either have it or remove it. Okay, if I have it, then the array will stay the same. If I remove it, then I can add the multiplication of all these three, increment this to this, increment all the numbers before this to this by one. Well, let's try. Will this be a DP of vector? It is very bad, actually. Let's see the editorial only for this. I don't think I would like to do a DP of vector. Oh my god. Hmm. I don't know. Whenever you find the answer to a large problem, yep. Okay, easy, easy, easy. Start from k is equals to 1. This is the partition. If partition dot size is equals to 2. A single matrix and no operation is required. I think I will need to watch the video on this.
Hey everyone, welcome back to Take You for the Boolean parenthesis problem, and they would have stopped so that this gets right into your head. Okay, so let's understand what's this partition DP all about. So generally, in all the problems where you'll be said to solve a problem in a particular way, remember this: solve a problem in a pattern. Now, what is the pattern? For an example, whenever you 1 plus 2, answer is different. But if you put it like this, then the answer is different. Like if you or DP, remember this: whenever there are multiple ways to solve, and probably they will ask you to find the best possible way, that's when you relate the problem to partition DP. So generally, how will you solve a partition DP problem? DP, there will be a different set of rules. So let's understand. So generally, in all the problems, you will have an array. In almost all the problems, you will have an array. And as you saw over here, you solve this portion at first and then this portion. Or given an entire array, and you will have to solve it probably this portion at first and this portion. Or probably it can be you have to solve this portion at first or this portion. Or probably you will have to solve this portion at first and this portion. So you will have to try out, given an entire this will be the ending point. Okay. And the partitions can be this, where you solve this and this. So there can be a lot of partitions. Partition k can be here, partition k can be here, partition k can be here, partition k can be here. It can be anywhere. So there can be multiple parts, be like this, and do the in a pattern that can be solved using partition DP. And you have to basically, I can say, whenever you try to partition it in this way, you have to solve this portion, which you can call from I to k. So this portion, if you solve it like this is nothing but f of I to k. And if you solve this is nothing but k plus 1, 2. So similar pattern of problems can be solved using partition DP. So I that we will solve will be MCM. So assume I give you three matrix of B, which is 30 cross 5. Can they be multiplied together is the question. Can they be multiplied together is the question. And the answer to that is yes, right, but they can definitely be multiplied. Why? Because if you have done maths in your school, you know, if
The second of this is equals to the first of this.
this guy, if these guys are equal, if the column of the first matrix is equal to the row of the second matrix, then the multiplication is possible. And how many operations do you require? It's how many operations do you require in order to multiply this? That's very simple. You take this guy 10, you take the common guy 30, and you take the other guy 5. So the number of operations or the number of multiplications required in order to multiply both the matrices will be 10 cross 30 into 5, which is somewhere around 1500 operations, if I have done the calculations correctly. Yeah, I have done it correctly. Now, what is these operations now? If you know, if I'm multiplying some matrix like this, how many operations we generally do? So this is nothing but multiply 2 of this size 1 with 2 into 3. So plus 1, that's easy to find. You write the first guy, number 6 that you need to know. So assume I give you these three matrices. Let's again try to write it. 10 cross 30, B is 30 cross 5, C is 5 cross 60. Now, if I ask you to multiply them, what are the ways that you can multiply? Obviously, multiply AB, operation. Now we'll give a matrix of n. If I try to sum it up, this will be 1500 plus, I think, 500. So that's one of the ways. Or maybe the other way. I can is n cross 1000. If I multiply first AB and the resultant with C, then I'll just take 4500 operations. Is there any other way? Obviously not. So what I figured out was the minimal operations required. Yes, the minimal operations required print to multiply. So for an example, if I take 4 matrices A, B, C, D, what can be the different ways? I can be like with B plus C. So whenever such a problem arises, you think of partition DP. Yes, you think of equals of 30, 40, 15 is 5. This array resembles the dimensions. Let me explain it. So A of
I understand the question.
2. For the third matrix, the dimension is A of 2 into A of 3. Thereby can I write for any given input, the ith matrix will have a dimension AI minus 1 into AI. Makes sense. Yeah, favorite. Like, makes sense. So I can say I have figured out this, that the dimensions are given in this way. For any ith matrix, the dimension is A of I minus 1 into A of I. Okay. So you will be given this dimensions. You know the number of matrices are 4. Tell me the minimum number of operations required in order to multiply these matrices. This is the simplest question. So I hope you have understood the question, right? So how do you solve this problem? Definitely. The way is partition DP. Again, whenever there is a pattern of DP, you have certain rules. Yes, you have certain rules. Rule number 1, start with entire block. Remember this, start with entire block or array. What does this mean? Over here we have 4 guys. So you say the function, hey, take the 4 guys and give me the answer. Yeah, you say the function, take the 4 guys and give me the answer. Like, it will be something like this. Let me just explain. So if I'm writing A, B, C, D, so these are the 4 guys. You start with all the 4 guys and you're like, okay, hey, listen, how can I solve this? I can either go like A, B or C, D. I can either go like A, and probably it's B, C, D, or probably I can go like A, B, C or D. Correct? So what you're trying to say is, okay, I was solving this. Now what I'll do is I'll try to break the problem down into smaller problems. How can be the smaller problems be? It can be A, B, C, D, or it can be A, B, C, D, or it can be A, B, C, D. So what I did was I took the entire problem, broke it down into something smaller. I'll try to solve it. And whichever way gives me the minimal will be my answer. So you will always start with the entire portion. You'll always start with the entire portion. Remember this. And you can always try all partitions. Partitions are possible. Let's say over here partition was here. Over here, like, you cannot again solve the entire thing. So there are 3 partitions. One is here, the other one is the middle, and the other one is here. There are 3 partitions. So probably you can run a loop to try out all partitions. Probably yes. Like, so run a loop. I'll explain you the loop. Run best possible 2 partitions. What do you mean by 2 partitions? Let's understand this. 2 partition. 2 partition. 2 partition. Which 2 partition is the best? Which 2 partition is the best? You return it. So 3 steps. Start with the entire block. Try all partitions because you're going to try out every possible way to solve it and return the best possible 2 partition. That's it. So you take the entire problem, break it down into smaller problems, every possible smaller problem, and you try to solve it, and you return the best possible partition that was like the best possible sub problem that you could break into. That's the straight funda. Okay. So something we've understood that we have to start with f of ij, right? That's for sure. Now what was given to us, like, we knew that we had A, B, C, D, but we cannot think in terms of A, B, C, D. You have to think in terms of the array. Let's understand. You have to think in D. 40 was nothing but third matrix was 30 into 40. What I can say this D? Where? If I'm looking for A's size, it's this guy and the previous guy. If I'm looking for the B size, it's this guy and the previous guy. If I'm looking for the C size, it's this guy and the previous guy. Something to the formula that we decoded. Thereby you can solve. My I will start here, that's the starting point because that's what A is. My J will be the ending point. My D will be the ending point rather. Thereby I can say the starting point is 1 and the ending point is n minus 1. Over here, can I say, please solve me 1, 0, 1, 2, 3, 4, 1, comma 4. Please solve me the matrix 1 to 4. In
Yes.
what way returns the minimum multiplications to multiply matrix 1 to matrix 4. Remember this. It is the minimum multiplications to multiply matrix 1 to matrix 4. So we have got our start point, which is 1 and which is n minus 1. So every time the problem will start over here with f of 1 comma n minus 1. In other problems, you have to determine in this way. Like over here, since a was meaning this guy, like this guy into this guy, thereby is I started here. In some other problems, I might start here, j might end here. You have to figure where does your means. It states first step done. I'm having an entire this ij. Let's look. Ij actually shrinks. Whenever you will do partition, they will shrink. They'll shrink. So initially this is this much. Then a shrink will happen. Then a shrink will happen. Then a shrink will happen. What is the minimum that you will go? Ask yourself. If you like
Yes.
Trevor, the minimum that we will go is nothing but when it's a single array. So the base case is very simple. If I is equal to j, came down to a post, what are the number? We figured out the piece of matrix, and thereby I can say we can easily return 0 because the number of operations will be 0. Start with the entire block. Done. Base case has also been written. Wow. So let's talk about the second point. Try all partitions. So let's go back and take the same example. This is the example given where we have this as the starting point, this as the ending point. So if I just write A, B, C, D, that will make you make things easier. Can I say I can have something like this? I can do a multiplication like this where I again solve this portion. Or I can have something like this where I solve this and I solve this and then I just add them up. Or I can have something like this where I solve this and I solve this and I add them up. Like, yes, right, but that actually makes sense. So can I say, if I probably, if I run a loop k, because first partition is this, the second partition that I can do is this, the third way that I can try is this. So can I say, if I run a loop from I to j minus 1, if I run a loop from I to j minus 1, for the first time, can I say it will be something like the first partition will be I to k and the other partition will be k plus 1 to j. We need to understand why j minus 1. I'll explain you that. Let's understand this. Let's take this example and try to write the values. 0, 1, 2, 3. So where is k? K is trying to go from 0. Let's try to write down the indexes so that this gets better. So k is basically running from 1 to 3. So what am I saying? 1 to 1 and 2 to what's j? J is 4. So basically the first time, whenever k is for the first time, whenever k is 1, what happens? I'm saying 1 is to 1, which means just this guy. 2 is to 4, which means this guy. Next step, when k is 2, I'm saying 1 is to 2 and 3 is to 4, which means 1 is to 2 and 3 is to 4. Or I can say, if k is 3, I'm saying 1 is to 3 and 4 is to 4. Does that make sense? I'm basically trying to have these because if you go till here, because the right is makeover, I will do k equal to I plus 1 and j till j. I'm like, okay, if you do this, then the partition will be
Hey, bro. Yo, yo,
I
yo.
to k minus 1 and k to j. That's it. If you're running the loop from here to here, which means 2 to 4, then let's see what happens. If I is 2, which is the initial case, then it will be like 1 comma k minus 1. So 1 comma 1 f of 2 comma 4. I is, rather k. If k is 3, it will be 1 comma 2, 3 comma 4. If k is 4, it is going to be 1. Then you will do a partition from I to k and k plus 1 to j. Or if you run from I plus 1 to j, you're going to do a partition from I is to k minus 1 and k is to j. Both of the ways are, I know, very simple. What do I need to run? I need to run and steps. So let's understand this because second
Steps is the most difficult thing. Yeah.
point is kind of half done. Written the best possible to partition. Let's understand this. This will give me some answer. This will give me some answer. This will give me some answer. And what do I need to take? I need to take the best among them. So let's understand how much answer, like if I do it f of 1 1, f of 2 4, how much answer does this basically gives me. So A was 10 cross 20, B was 20 cross 30, C was 30 cross 40, D was 40 cross 50, correct? So we had four matrices, and this was f of 1 comma 1. So 1 comma 1 means one block of A, which will be 10 cross 20. And can I say, if you're multiplying BCD, if you're multiplying BCD, at the end of the day, what will be the resultant? What will be the resultant matrix? So if you
20
can try
cross
multiplying, it will be
this.
like B is this, C is this, D is 40 cross 50. So
20
this is
cross
nothing
50.
but A. But if you multiply something as BCD,
20 cross 50.
what is the resultant matrix? So assume you multiply this, you get 20 cross 40. Assume you multiply this, which is 20. If you do it the other way, it's 30 cross 50, 20 cross 30. And if you again do it, it's 20
So three values, I think.
cross 50. No matter in which way you do the multiplication, the resultant matrix will be of size 20 cross 30 only. So I can say 20 cross, rather 50, my bad, 50. So that's the resultant size of BCD. So if A is this, BCD is this, what are the number of operations that you'll be requiring in order to
I think I got this wrong.
multiply A and BCD? Because A was a part, BCD was a part. In order to
Let's see. Let's see. So what I return vector in vector in I return find the minimum now and max. Is also max of solve of k comma starts from I comma k of 0 comma that's my if uh let's make this answer as a vector of size 3. All the values at initial are int min. Cool. So, I comma k of 0 into solve of I plus 1 comma j. Sorry, so of 0 greater than answer of 0, if that is the correct answer, is equals to multiplication of this, comma, uh, what no, bro? Uh, so let's store this value somewhere. Like the in first part is equals to mm, this, comma, second part is equals to this. Cool. Second part, if that is greater than answer, then answer is uh this. First part of 1, second part of 2. Should work. Let's see. Ah, any other semicolons that I'm missing? Yes. Okay. Huh? If okay. So huh? Hmm? Okay, return 0 comma 0 comma 0. Does that make sense? Yeah, I think it does. It does not actually. 0 comma J I. Ah, I plus 1. Should I start from I plus 1? No. 0 comma I minus 1 J. Oh, nums of this should be. Array, sorry. I I LeetCode uses nums a lot, so I'm just in that zone. This should work. So what am I doing? When I is equals to j, the let's say I and j are here, then I return this would be the starting and this will be the ending of the matrix. Cool, which works. Hmm. And the answer would be 0. Something that I'm doing wrong because I have to add somewhere. I have to add somewhere. Ah, this is wrong. This is wrong. I'll have to watch the video, I think.
To multiply them, can I say the number of operations will be 10 cross 20 cross 50? Where is 10 actually? Can I say, if you remember well, 10, 20, 30, 40, 50, I was here, J was here, and K would be probably here for this case, right? Where is 10?
Let's just see. Am I returning the correct things? I don't think I'm returning the correct. Somewhere I have to add. Where do I do that addition? So what is happening? This is getting divided into two portions from here, multiple portions. One here. So each level I add. On each level I add. Ah, greater than answer of 0 plus second. First part of 0.
Let's see, where is 10? Can I say whenever you try to multiply A and BCD, A and BCD, where is 10? 10 is right before I, A of I minus 1 multiplied with, let's see, let's come back. Minus 1 multiplied with, let's see, let's come back. Where's 20? Can I say 20 would be here? You'll be like, it's I. It's actually not I, it's K. Try taking some other partition, I'll show you that. It's actually K. So what you can do is, you can easily write array of K now. How's the other one? The last one is 50. Where's 50? At J. So the last one is array of J. So basically that signifies is you had two parts. So when you combine them, the number of steps required will be this, right? Now you had two partitions. What are the two partitions? F of I k and f of k plus 1j, because BCD in itself will take some number of steps. BCD in itself will take some number of steps to get multiplied. So I can say, okay, the I comma k will take some steps. Let the function give me that, because I want the minimal number. Function will give me that. Or k plus 1 comma j will also, the left guy will take some steps, give me the minimal. The right guy will give some steps, give me the minimal. And these will be the steps if I do a partition on k. If I do a partition on k, right? And what I can say is, okay, I need the minimal of all. Probably I can store a mini equal to a bigger value, and I can say mini equal to minimal of mini comma steps, because I need the minimal
Cool, 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 cool.
among all. So this will make sure it gives me the minimal among all. And in this way, I have pretty much, remember,
This is Geeks for Geeks. Uh, I don't prefer using Geeks for Geeks, but it has some better some problems that are on there and not on date code, which are asked. Like it has much more basic level of understanding of those similar problems that are on date code. So, uh, so yes, this MCM is on lead code. Is not on lead code. Lead code has another partition problem, which is minimum cost to cut the stick, but we want to do this. So steps is equals to now array of I minus one plus array of k plus array of j plus solve of I comma k plus solve of I k plus 1 comma j equals mini comma कौन सा कंपनी में वर्क करता हूँ? हाँ अभी तो मैं एक्सेंचर में करता हूँ पर पढ़ रहा हूँ इंटरव्यूज के लिए करना है कुछ ओ थैंक यू भाई थैंक यू थैंक यू थैंक यू थैंक यू हाँ यार दिमाग खराब है ये पार्टीशन किया स्टेप्स सही है स्टेप्स सही है Shit.
Hey everyone, welcome. It is the minimal prefer run easily write array of k now. If I do
ये सही है मिनी इज min ऑफ Uh, mini, 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 mini. Ah, oh, क्यों नहीं आ रहा? इसको return zero. Mini, चलो इसमें debug भी नहीं कर सकते ना? Can't debug on GFG. So it goes to here. Now k is equals to 1, k is smaller than j minus 1, j minus 1, and k plus plus. Now steps is equals to I minus 1, 2, 3,
Do a partition on K. Minimal of all. You will make this is important. This was MCM, so you computed the number of steps. There might be some other the record 50. Imagine some 50 steps. That's what the number of steps will be, no matter how you 50. And there was where we are given a matter. What about the base case? Base case is very simple. Depending on how will be from I to B in the minimal, so probably you can keep the minimal mini to be very simple. It's array of I minus 1 into array of it. Once you've got k plus 1 in the previous partition steps, you basically replace mini equal to steps, and at the end of the day you can easily return to a certain cases you have to apply memoization. It's one, but it is giving time.
Ah, why is it working for him and not for me? One, two, n minus one. That's what I am doing. Ten to 33 into 60. Let's try to run that. What was the input? Excalibur. Let's do a run. Then 35, 60. 10, 35, 60. हाँ वो तो समझ में आया पर क्यों नहीं हो रहा? होना तो चाहिए ना मिन ऑफ meaning comma steps. रीजन पता चल रहा है? Okay, so first I is here and J is here. Okay, I J at first. Now in the first operation, what happens? We go K is here. So first thing that we do is then into 30 into 60 plus becomes here. So I and j will be equal, and second part will be I and j. I becomes here 5 and 60 will be the second part. Then I come here. These are the two partitions that happens at first. Let's see. I is equals to 1, comma j is equals to 1. This is the first partition, and the second partition is I is equals to 2, comma j is equals to 0, 1, 2, 3. This is the second partition. This will return 0, this will return, and steps will be 10 into 30, 10 into 30 into 60. Okay, now k comes here. In that case, the partition would be 10 into 5 into 60, and into 5 into 60. Now I is equals to 1, j is equals to 2. This is the first partition. And 2. Second partition would be, okay, so only 2 here, so I can, j is equals to I is equals to q plus 1, which is 3, j is equals to 3. Okay, now this will give us 0. This will also give us 0. 2 and 3. Okay, I is at 2. Let's say I is at I is here and j is here. Okay. Now, in this case, how will this work? K will start from I 30 into 5 into 60. So if we run this logic for I is equals to 2, j is equals to 3, so first k will be 2, and the answer here will be 30 into 5 into 60. Okay. And first partition would be first partition would be I to k. So I is equals to 2, j is equals to 2, which will give us 0. Instead of writing it this way, let's write it 0, 0, 0. Uh, Now k will become j, and the second partition, because k will never become j, and j. I think the code does not flow inside the for loop. What do you mean by that? Uh, it does like it's inside the for loop. Okay. Can I post a screenshot of this? I can't post photos here, but I think you can see the code and you can screenshot it right now. It does flow. And the second partition for this will be k is equals to 3, j is equals to 3, which will also give us 0. K is equals to I I is equals to k plus 1, and k is here at 2, so 3, and j is equals to j for the second. And this will also both will get 0, but let's do this itself will give 10 into 30 into 10 into 30 into 50. Okay, so and whatever the answer for this, it will give us 0. 0. So when I am at this, it does a mini of both of these and gives us 0. Ah, which is weird. So not many of both of these, sorry. So it this plus this plus this. Okay. This gives us 0. This gives us this plus this plus this. So this gives us 5 into, and that's how we get the answer here. Should work. I don't understand why it's not working. Let's just see. I, J, vector I have here. This dot array is equals to array, which is correct. And is equals to array dot size, which is correct. I don't need n though. Oh, I need n. Uh, I is equals to j, return 0. Int mini is equals to 10 raised to 9. Int max. Uh, k is equals to I. K smaller than j. K plus plus. Oh, हाँ हाँ हाँ, क्या दम है भाई। शैडोइंग हो गई भाई, शैडोइंग हो गई। ओ भाई। So this variable got shadowed. This shadowed this variable. Sad. TLE आएगा, TLE. Uh, let's memorize vector, mm, vector, uh, vector, memo. Let's memorize. Memo is equals to vector int of size n comma shadowing हर language में होता है. So when you have a variable that is, let's say, mini, and mini is in this scope, so it is in this braces. Okay, so when I declare a new variable mini in this scope, in this braces, or uh, it does not relate to this mini. So this mini would when I had, जब मेरे पास ये था int mini, उस point पे it was a completely different mini. It was not the same mini as this. तो एक नया मिनी क्रिएट हुआ जो इस स्कोप में ही था, सिर्फ इस ब्रेसेस के अंदर ही था। वो उसका यूज हुआ और फिर बाद में फॉर लूप का एक इटरेशन खत्म हुआ, तो वो मिनी डिस्ट्रॉय हो गया। फिर बाद में जब सेकंड टाइम आया तो मिनी वापस से क्रिएट हुआ और डिस्ट्रॉय हो गया, पर इस मिनी में कोई चेंज नहीं हुआ। तो ये शैडो ही होता है, हर लैंग्वेज में होता है, हर लैंग्वेज में सेम है, जावास्क्रिप्ट, जावा, सब जो भी। वेक्टर एंड size. I don't know if we can actually memorize this, but let's see. Let's apply the general memorization properties, because this K does not feel that good for memorization. Mm. Yeah, that's work. Memorization works. Now let's write the top-down version. So where is I starting from and J starting from? And J. How will I write the memorized version? Let's see one thing. So let's do one thing where we first let's do the base case for the top-down version for I is equals to 0, smaller than n, I plus plus memo of I j is equals to 0. So we can now remove this. Uh, This should work. Uh, did I do something? I. Yep. Cool. Now for and j is equals to n minus 1, j greater than equals greater than 0, j minus minus for and I. Let's do for and I is equals to, should start from back opposite side n minus 1. Will I ever reach n minus 1? Yes. Uh, I think it should be n minus 2, but let's see. I greater than 0, I minus minus, and j will start from the start. So equals to for and j is equals to I, j j smaller than equals to smaller than n, j plus plus. Let's copy this, paste this. हाँ बहुत जल्दी हो गया. Ah, Should work. Mini. So let's print this first. Memo X. Cool. This is correct. Now, how should this be filled? Oh, uh, memo. And this all should be 0. It's minus 2 for 9. Where is that minus 2 coming from? Ah, this one. Cool. This one. We have a top-down version. We can delete a lot of code now. Cool. Can we optimize this? Let's see. I don't think we can optimize this. This is useless. Uh, is there a way to optimize this even more? Let's just see once. What is the time complexity right now? N, N, and at max N. So N cube is the time complexity right now. What is the space complexity N square? I think this is it. Yeah, MCM. Yeah, the ones must be the bottom of also. Let's watch his video once fully.
Hey everyone, welcome off easily do. So see that there is no further time limit exceeded because we have memorized all the states. Now, will this be accepted in an interview? Yeah, in interviews, the tabulation stuff. But yeah, in IDs, it will probably give TLE. But again, the reason of setting the time limit strict is so that you go and learn the tabulation, the time complexity of this particular method. So what we have done is memorization. So what is the time complexity? If like strived as n into n states, you see, there's a loop. Thereby, complexity of big O of n square as of now plus stack space. Yes, there is definitely a stack space of big O of n. This is auxiliary stack space because if you go on tabulation. So guys, if you watched the video till now, I'm definitely sure that you've understood the part of tabulation. That's what the memorization will be. In the next lecture, we will be doing the tabulation. So guys, if you watched the video till now, I'm definitely sure that you've understood the partition DP. So just in case you did, please make sure you like this video and if hey everyone, bottom of tabulation. Think that go back to the code. Have of one z minimum the changing parameters. One was very simple, I. The other one was G moved. If a one bigger problem to break the smaller cost. Yeah. Where's the J running? you would have done the which will always 0 to n minus 1. So of n or the next thing, and over here you just have dp, keep n minus 1, and you can just omit this off. That's what you will generically return. Okay, the base case, I forgot to write the base case. So it's I equal to 1 till it is. It's 2 o'clock in the night. Cool, guys. Then there's a problem, right? So just make sure you be a bit practical when you try to write the for loops. And if you are, then you can easily solve this. Also, time complexity, n cube space n square, no auxiliary space being used. So, guys, I hope you have.
Min cost to cut a stick. Given a wooden stick of length n units, the stick is labeled from 0 to n. For example, stick is of length 6. Given integer array cuts where cuts of I denotes the position you should perform a cut at. You should perform a cut in order. You can change the order of cuts you wish. Okay. The cost of cut is the length of the stick per cut. The total cost is the sum of all cuts. Cut a stick, it will split into two smaller sticks. The sum of the length is the length of the sticks before the length before. Okay. Oh, let's see. Given a wooden stick of length n and n units, the stick is labeled from 0 to n. For example, the stick of length 6 is labeled as below. Okay, cool. Given an integer array cuts where cuts of I denotes the position you should perform a cut at. Okay. You should perform a cut in order. You can change the order of the cut as you wish. Okay. The cost of one cut is the length of the stick to be cut. The total cost is the sum of all costs and all cuts. When you cut a stick, it will split into two smaller sticks. Sum of their length is the length of the sticks before. Please refer the. Okay, cool. So we have this stick and we can make cuts at position 1, 3, 4, 5. Okay. And the cost whenever we make the cut is, let's say, for when we make a cut at any of these position, it will be 7. If we make cut on any of these position, it will be 7 minus 1, 6. Cool. So first cut is done to a rod of length 7, so the cost is 7. The second cut is done to a rod of length 6, so the 6. Third cut will be done to a rod of length 7 minus 3, 4. So 4. The fourth cut is done. Yeah. Cool. So similar partition problem. Uh, I is equals to 0, j is equals to 0 when I and j are equal. Then at that point we return 0. and we run a loop. Oh, I'll be. Oh, let's do this also. Cool. So we start from this position and this position. Now the length is 7, or we have I and length. I and length. We have I and length. I will tell us where all we can cut. Yeah, I and length. Now, or I and J only. I and J. Now, but I need, but I need to know the length. I need to know the length. I and length. I, J and length. Uh, what could I do? So I start from here. I can partition at this point, at point 1. So it will make two cases. It will add 7 and make two cases where add 7 and then I have to solve I plus this and this side. So I'll have to solve 3 to 5. I can partition at 3. So I, J and length. If I partition at 3, then I have to solve this side and at this side. If I partition at 4, then I'll have to solve this side and this side. So I and length seems fine. Let's write the base case, base case. I, J and length. equal if I is equals to j, then return 0 and mini is also in the max for int I is for int k is equals to I, k smaller than j, k plus plus length. Steps in steps is equals to length plus this portion of the array. So what will be this portion of the array? Where will it start? It start at k minus 1, or it will start at I of I minus 1. Start at I, comma, it will end at k plus solve of k plus 1, comma, j, comma. Now let's calculate the length. Okay. Length will be dependent on what will be the length of this side. Length minus so Okay. Cuts of I minus I, comma. This seems very wrong. Like does not seem that elegant. Length minus cuts of I. Length minus cuts of I minus I. Can I do this with I and length? I should be able to do this with I and length. I should be able to do this with I and length. No need of J. If cuts of I, but let me tell you what I'm trying to do. So I'll start I and length. I'll have now if cuts of let's say if cuts of I is greater than uh I'm here. Length will become 6. Okay. And this length is 1. Now Okay. Let's say first cut is at 0. Okay. Now, can I pass this? Ah, how to do this? Okay, so if first cut is at 0 at index -1. Okay. Now the length is 7. I can do it with Iron Man. Make a cut at 1. If I make a cut at 1, I make a cut at 3. Okay. Comma int j. Okay. Which will represent the start and end for int k is equals to I, k is smaller than j, k, k plus plus. Okay. Now steps is equals to if smaller than n, then uh, left or right do I make left, left, then at that point cuts of j, or if it's not, then n minus of j. So if I make a cut at 2, this size will be 3. At 3, if I make, so this size will be 3, this size will be 4. Um, Plus all of I comma k I comma k comma 1 plus solve of I comma k, sorry, k plus 1 comma j comma r 0, right? If I is equals to j, return 0. If int mini is equals to int max mini is equals to min of mini comma steps 0 comma s minus 1 and s is equals to I this dot n is equals to n this dot cuts is equals to cuts should work, I think. Uh, q is equals to I Ah, at the start, I have to solve for that. If left side, then the length is cuts of j. If right side, then minus cuts of j. No, this is not correct. This is not correct. Or instead of this, let us take I will be 0 and this will be n. Let's take this 0 and n. Okay, A is equals to 0, K smaller than S, K plus plus, okay? Taking all of these. So if cuts of K greater than I and cuts of K smaller than N, smaller than J, then only I can do this. So we have a full size stick right now from 0 to 7. If cuts of K greater than I and min is equals to min of J minus I plus the left side. Left side will stall left side will start from I and add cuts of K plus right side stall of K comma and add J return min. This should work. No left right comma min. Now, now how do I return? To found is equals to 0. Can remove this. TLE, I'll get TLE mostly, but I do want to try and submit. Yeah. Let's memorize this vector int of vector int memo is equals to vector int of size n plus 1 vector comma vector n of size n plus 1 comma minus 1 if memo of I j not is equals to minus 1, return memo of I j memo of ij equals to 0. Should submit memory limit exceeded. Because n is too large. 6, 4. N square. We'll have to work on it so it is a function of cuts. I and j are related to cuts length, not the length of the bar. Ah, so this does not work. IJN length. IJN length seems the most viable option. Seems IJN length for me right now. Oh yeah. IJN length. This does not work. IJN, comma, in, yeah. If I equals to J return 0. Cool. Where references 0 to n minus 1. All inclusive. Cool. S minus 1. Okay, cool. For mini max return mini plus length. Cool. For int k equals to I k smaller than j k plus plus. Cool. J is exclusive. Mini equals to min of solve of first this partition. So I inclusive, comma k minus 1. If I make a partition on this element, let's say I make a partition here, okay, no k minus 1 because it is exclusive, k is not included, plus solve of k plus 1, comma j, comma mini. Cool. Now, how do we find length? Comma, if I make a partition here, to the left side, the length would be cuts of k. Let's say I made the first cut at 1. and the second cut I'm making at 5. Okay, so cuts of so five length between 5 and 1. Okay, minus cuts of I. Wait, Ah, let's try to debug. 05. Huh? Cool. So k is equals to 1. Let's make a cut here. So in that case, 0, I'll make a partition here. So make a partition here. If I make a partition here, I have to watch the video.
Hey everyone, welcome back to Take You Forward. Today we will be solving an interesting problem on partition DP, which is minimum cost to cut the stick. Now, what does the problem state? The problem state, you'll be do a cut at one. I will have, okay, fine. Yes, this is the lowest that you'll get is of length 16. You can't go lower than this. Okay. So before moving to the solution of this question, let me tell you about the sponsor of this video, the Hirect app. One more thing, the found you're waiting for. So how do you approach this problem? Because you will be given something like 1, 3, 4, 5. Like this is in cuts. You can either start with 1 as the cut. You can either start with 3 as the cut. Complete stuff. Okay, treat this as 1, 3, 4, 5 as the complete stuff. I can. And then can I say if I make a cut at 4, if I make a cut at 4, if I'm making a cut at 4 for sure, I can also start with 5. Or I can also start with 3. So I can either start with 4, I can 7. So I'll add up 7 the first cut at 4. The answer that I'll add is 7 because that is the initial length of the stick. At least at the first step, the length will be the complete stick. So can I say now I'm solving 4, 5, 6, 7 because I made a cut at 4. 5, 2. Let me just visualize it again. I'm having 1, 3, 4, 5. Okay. I know this is the partition that I'm solving. This is a partition formula. It'll give me the length of the stick. I will show you length of the stick. This is the length of the stick. If I apply this formula, it'll give me the length of the stick. Is the this j plus 1 minus cuts of I minus 1, which is this.
Okay. Yeah. One comma is minus.
7 minus 0 is 7. This is the length plus 1 minus cuts of I minus 1, which is this. 7 minus 0 is 7 rather, which is this j plus 1 minus cuts of I minus one, which is this. If I this guy, which is I, because I did a partition on index, I solved it from I to index minus one, this small partition, and index plus one to j, this partition. So I just took an cut, and I'll be solving these couples. And since they are sorted, they're independent. And since they're independent, I can just solve them independently and add up the answer with the current answer, which is this. Now you might ask, how is this working? I'll show you after I write the code how is this exactly working. You'll get a clear cut idea. But before that, let's start writing the code. So you've understood that it's going to be a partition. Like 1, 3, 5, 8 was initially given to you. You will just sorry 1, 3, 4, 5 was given to you. You will insert and from here. So I can start with this. I can take any one of the first cut. So thereby, the cost will be 0 if no partition to be solved. I know what's one. I've already showed you why, and I'll prove this one. I have to solve the right guy, which is index plus 1 comma j, for sure. The left guy and the right guy is what I need to solve. Perfect. And since I need the minimal cost, probably I can keep it as int max. And I can just say minimal equal to minimal of mini comma cost. And at the end of at any of the index, and then I go to the left subproblem, to the right subproblem, get it. Okay. Now coming back to this portion, which a lot of you probably did not understand. So imagine that this is somewhere around 12. You mean it was at I, and this will be the ij over here. Okay. Now if you carefully observe, I say I will BP. So now what I'll do is these couple of guys so that we can easily get the length is because we know the first partition, the left partition initially will be at 0 and the right partition initially will be at 10. That's why I have just inserted it. Make sure it's sorted. That is something which you have proved. In order to make two subproblems independent, we have to sort it. Okay, so please make sure you sort it. If we're using sort, we know we have to use hash includes. Please.
Cool, we have our answer. And now what we can do is this. Now we can memorize it of size S, size S, not equals to -1, number of ij. So it should work. 55 percentile. Let's when I is greater than j, all of them will be 0. So instead of that, let's just make all of them 0. Um,
or I equals to int I equals to s minus 2, I greater than equals to 1, I greater than 0, I minus minus for j equals to I j smaller than s minus 2, j plus plus. Let's copy this. Paste this. No more memo of I, comma k minus 1, memo of k plus 1, comma k. I greater than j, j minus minus. No. J equals to j equals to 1, j smaller than equals to I. You know, I equals to 4, 0, 1, 2, 3, 4. J equals to 1. If I have to do J plus 1, I should start J from the back. And if I have to do I minus 1, I should start I from the start, I guess. Let's just see. Mini right now becomes into max. K becomes K is equals to I. Please. So yeah, I more than equals to S minus 2 J plus plus. K is equals to 4. I plus I don't know how we'll do.
At hashing group. That's perfect. So you're trying out all partitions, and that's going to take partition. And right on the code over here, you'll say dp of ij equal to whatever mean. I think c plus 1 cuts and let's copy paste equal to minus 1. So if you run this, this should be running fine. Yeah, this is two changing parameters will yield to n. Two changing parameters I and j will give you n square or square for partition. It's 0 only. So instead of doing anything, what you can do is you can just declare a dp of c plus 1 and c plus 1 and make it entirely 0. Two changing variables. Where is I being called? Just go and look. You're calling it from 1, comma n. This is your I, this is your j. You're calling I from 1. This happens to go like this. So I will go from 1 to n in recursion. I will go from 1 to n in recursion. So in tabulation, it will be opposite because tabulation is bottom up. You take those bottom answers and you compute it. So n to 1. What will be j? J is going from n. Shrink j is n, and then if you know this pattern, it's going to be a cakewalk. So if you have followed followed the DP series entirely. You know this pattern. I've taught you how to make tabulation easy. So if you know this pattern, it's going to be a cakewalk stuff. Don't worry about that. Let's write the same thing. So no base case in J less than equal to n and J plus plus.
Okay. Huh? I is equals to n. Okay.
Perfect. You know the base case is this, which will be 0 always. So you can say this, we don't need to perform because already everything is assigned to 0. Copy every stuff over here. Copy the recurrence. I'll just copy paste the recurrence. See how easy it is. Let's copy paste the recurrence. Remove the return. Over here, dp of index plus 1, j. So yeah, that's what the first and right. And I've taken this, and this will be dp of 1c. dp of
Cool, we are done with this. I think that's ah, too much, too much, too much. These are hard DP questions, and obviously they are not meant to be easy. They are meant to have a toll on your brain, and I'm happy. I'm partially solving them, not able to solve all of them. MCM is hard. LIS I was able to solve like all the hard ones also, but MCM right now I'm learning MCM. I think I've done burst balloons. No, I have not. Given an balloon index, each balloon is painted with number on it relevant to an. Okay, I think I know how to solve this. What did I try last time? Did it work? Basically, it worked. Basically, I think it gave me a theory. But now I know partition. So I'll be back. I'm done.